Chapter 7. Statements in QBasic. Topics covered: control statements, looping statements. Let us first revise the fundamentals of QBasic. Constants are the values that do not change during the execution of a program. Numeric constants, string or alphanumeric constants, contain only digits with or without decimal points, can either be positive or negative but cannot include any special characters, are used to carry out mathematical operations. For example, 24.12, 55 etc. contain letters, digits, special symbols or blank spaces enclosed within double quotes. Cannot be used in mathematical operations. For example, QBasic program 2*3 equals 6 etc. Variable refers to a location in memory that is assigned a name and its value can change during the execution of the program. Numeric variables, string or alphanumeric variables, contain letters and digits, cannot contain spaces or any special characters, store only numeric values. For example, number W1234 etc. contain letters and digits. For example, Kale J etc. Some basic statements in QBasic: print, let, rem, input, cls. Used to display a message on the output screen with the use of either a string constant, a numeric value, value of a variable or the result of an expression. Used to assign a value, a variable or an expression to a variable. Used to add remarks or comments in a program which are not displayed in the output of the program. Used to accept input from the user and assign it to a variable. Used to clear the output screen. Control statements in QBasic. When there is a need to execute a program under some specific conditions, the conditional statements, also known as branching statements, are used. These statements include if, then, else and select case statements. If, then. The most basic control statement in QBasic is the if-then statement. In a program containing this statement, if the condition in the if statement is false, the statement in the then part is skipped and the next command after that if-then statement is executed. Syntax: if condition then statement. Given below is a program which evaluates the conditions under the if-then statements and then displays the output accordingly. Rem comparison of two numbers: let A equals 25, let B equals 50. If A equals B, then print the numbers are equal. If A B, then print the greater number is A. If A B, then print the greater number is B. End. Output for the program using the if-then statement. If, then, else statement. The if, then, else statement is an extended version of the if-then statement. If the condition in the if statement is true, the statement in the then part is executed, and if the condition is false, then either the conditions in the next if-then statement are executed or the statement under the else part is executed. Syntax: if condition then statement s, else statement s, and if. Given below is a program which evaluates the conditions under the if, then, else statements and then displays the output accordingly. Rem comparison of two numbers. CLS: let A equals 25. Let B equals 50. If A B, then print the greater number is A. Else print the greater number is B. And if. End. Cyber tidbits. The end if statement can be used to end a multiple line if block statements, and it should be written before the end statement. Output for the program using the if, then, else statement. Using else if with if, then, else. The keyword else if is added to the if, then, else statement when there are a number of conditions in the program. If the condition in the if statement is true, the statement in the then part is executed, and if the condition is false, the statement under the else if part is evaluated. Further, if the condition in the else if statement is false, then the next else if statement is evaluated. Finally, if all the statements are false, then the statement in the else part is executed. Syntax. If condition 1 then. Statement S. Else if condition 2 then. Statement S. Else if condition 3 then. Statement S. Else. Statement S. And if. Given below is a program which evaluates the conditions under the if, then, else statements with the keyword else if and then displays the output accordingly. Rem comparison of two numbers. CLS. Print enter the first number. Input A. Print enter the second number. Input B. Input B. If a B then. Print the greater number is A. Else if a B then. Print the greater number is B. Else. Print both numbers are equal. And if. And. Output for the program using the if, then, else statement using the else if keyword. Select case statement. The select case statement allows you to evaluate the output with the help of multiple cases based on the values of a given expression. You can use this statement instead of creating a nested if, then, else program. Syntax. Select case expression. Case value 1. Statement S. Case value 2. Statement S. Case value 3. Statement S. Case else. Statement S. End select. Given below is a program which evaluates the conditions under the select case statements and displays the output accordingly. Rem printing January to June. CLS. Print enter any number from 1 to 6. Input N. Select case N. Cases equals 1. Print January. Cases equals 2. Print February. Cases equals 3. Print March. Cases equals 4. Print April. Cases equals 5. Print May. Cases equals 6. Print June. Case else. Print invalid input. End select. End. Output for the program using the select case statement. Looping statements in QBasic. When there is a need to repeat some commands in a program, looping statements, usually called loops, are used. These loops includes the for, next loop, the while, when loop and the do loop. Let us discuss them in detail along with their variations. For, next loop. Sometimes, there is a need to repeat the execution of a program for a specific number of times. In such cases, the for, next loop is used. Syntax. For countervar equals start to end. Statement S. Next countervar. Here, countervar is a numeric variable used as a loop counter. To learn the use of the for, next loop in a program, the steps given below are followed. Step 1. A start value is assigned to the loop counter, i.e. to the countervar. Step 2. Execution of the statements in the next statement is carried out and then the loop counter is increased by 1. Step 3. Step 2 keeps going until the value of the loop counter reaches the end value. Given below is a program which evaluates the statements in the for, next loop and then displays the output accordingly. Rem printing number series from the input number to 9. CLS. Print enter a number from 0 to 9. Input n. For I equals n to 9. Print 1. Next one. End. 4. Next loop with step. Every time a for next loop is executed, the loop counter is increased by default. However, if you want it to be increased by some particular value, you can use the step keyword with for next loop. Syntax. For countervar equals start to end step value. Statement S. Next countervar. Given below is a program which evaluates the statements in the for next loop with the step keyword and then displays the output accordingly. Printing number series from the input number to now with a difference of 2. CLS. Print enter a number from 0 to 9. Input n. For I equals n to 9 step 2. Print 1. Next one. End. You can also use the negative value of the step keyword. For example, given below is a program which evaluates the statements in the for next loop with a negative value in the step keyword and then displays the output accordingly. Printing number series from 9 to the input number with a difference of 2 in a reverse order. CLS. Print enter a number from 0 to 9. Input n. For I equals 9 to n step 2. Print 1. Next one. End. Nested for next loop. When we use one or more for next loops inside another, it is termed as a nested for next loop. The outside loop is called the outer loop and the loop S, which is inside the outer loop is /r called the inner loop S. There are some points which you must keep in mind while nesting loops. Output of the program with the use of the for next loop with negative value in the step keyword. You can insert a maximum of inner loops inside an outer loop. The loop counter must be different in every loop. The order in which the loops are executed from inside to outside, i.e., the innermost loop is executed firstly, then the second innermost, and so on. The outer loop is executed at the end of the execution of all the inner loops. Given below is a program which evaluates the statements in the nested for next loops and then displays the output accordingly. Printing a pattern using a looping statement. For outer equals 1 to 10. For inner equals 1 to 10. Print asterisk. Next inner. Print. Next outer. End. While, when loop. When there is a need to execute a set of statements only when they are true, the while when loop is used. Output of the program with the use of the nested for next loop. If the conditions in the while statement are false, then the conditions in the when statement are executed, and if the conditions in the while statement are true, then the when statement transfers the control back to the while statement. Syntax. While condition. Statement S. When. Given below is a program which evaluates the statements in the while, when loop and then displays the output accordingly. Printing a number series with power of 2 up to 100. CLS. 1 equals 1. While 1 equals 100. Print 1. 1 equals 1 asterisk 2. When. End. Do loop. While programming, when the exact number of times a loop is to be executed is not known, the do loop is used. There are two variations of the do loop: do loop while and do until loop. Do loop while. Same as the while. When loop, the do loop while executes a set of statements only when they are true. The only difference between the two loops is that the do Loop. While loop executes the statements inside the loop first and then checks the condition. Thus, the loop is executed at least one time even if the condition is initially not true. Output of the program with the use of the while, when loop. Syntax. Do. Statement S. Loop while condition. Given below is a program which evaluates the conditions in the do, loop while and displays the output accordingly. Rem evaluating the input number to be even or odd. CLS. Print enter a number. Input number. Do. If number mod 2 equals 0 then print it is an even number. Output of the program with the use of the do, loop while. Else. Print it is an odd number. And if print enter a number. Input number. Loop while, number greater than 0. End. Do until, loop. The do until loop is executed as long as the condition is false. The loop terminates as soon as the condition becomes true. Syntax. Do until condition. Statement S, loop. Given below is a program which evaluates the conditions in the do until loop and displays the output accordingly. Rem evaluating the input number to be even or odd using the do until loop. CLS. Print enter a number. Input n. Do until n 0. If n mod 2 equals 0 then print it is an even number. Else print it is an odd number. And if print enter a number. Input n. Loop. End. Output of the program with the use of the do until loop.